Hello, math people. Today we're going to look at actually graphing a polynomial. So before we do that, I need to give you some information. A polynomial is written in the form of p of x, where p is just a polynomial in terms of x, a x to the n plus x to the n minus 1 plus x to the n minus 2, ... and that pattern would continue. So we call this a leading coefficient. It is the leading coefficient. It is the coefficient of the highest exponent. So a leading coefficient is the coefficient, the numerical number of the highest exponent. And that leading coefficient gives us some information about the graph. So if that leading coefficient is positive and the degree is even, so when I say degree is even, I mean like you have x squared, x to the fourth, x to the sixth, x to the eighth, all of those would be considered even exponents. If the exponent is even and your coefficient is positive, then your end behavior looks like this. Both ends are going towards infinity. The left end and the right end are going towards infinity. But if that leading coefficient is negative, but your degree is still even, again, that would be x squared, x to the fourth, x to the sixth, so on and so forth, then both ends would go towards negative infinity. So I'm going to say this approaches infinity, this approaches negative infinity, both sides. So, and you've seen this before because you've seen a parabola, like this is x squared, and you've seen negative x squared looks like this. Okay, so what does it look like when the degree is odd? So x cubed, x to the fifth, x to the seventh, so on and so forth, and your leading coefficient is positive. Then from the left side goes towards negative infinity, and the right side goes towards positive infinity. So as x goes towards negative infinity, y goes towards negative infinity. And as x goes towards positive infinity, y goes towards positive infinity. And as you would imagine, it's just the opposite when the leading coefficient is negative, and but your degree is still odd. So you still have x cubed, x to the fifth, x to the seventh, so on and so forth. But now your left side would go to positive infinity and your right side goes towards negative infinity. So as x goes towards negative infinity, y would go towards positive infinity. And as x goes towards positive infinity, y goes towards negative infinity. So knowing that, we can sort of sketch what the graph would look like. So if this graph, from this graph, we can tell what a possible graph looks like. Now this, if you were to graph this on your calculator, what I sketch will look nothing like it, but we can sort of see some of its behavior. So what we notice here is that a is negative. That's the first thing we notice. So we have a negative coefficient. The degree, the highest exponent, is 3. So it's a cubic function. So the number of possible zeros are 3, because remember, according to the fundamental theorem of algebra, the number of zeros cannot exceed the degree. And our domain for all polynomials is negative infinity to infinity. So what would this look like? So because my a is negative and my degree is 3, then it will look something like this. That would be its shape. So it could have as many as 3 zeros, and I'm just randomly putting zeros in there. I don't know where they are, but it will look something like this. And why did I do that? I don't know why I did that. I just made that up. But this is going to go through at least 3 times, so it could look something like this. Now, if you graph it, it probably looks nothing like this except for the end behavior. So on the next one, I have A is positive because A is 4. This is my A. My degree is also 4 because that's my exponent. And my domain will always be negative infinity to infinity. So because it's positive, it has, the number of possible zeros is 4, but the degree is 4. It has a degree that's even. So it's going to, its end behavior would look like this on both sides. So it's going to look sort of like this, 1, 2, 3, 4. Okay? And I want you to pause the video and do the last 2. Okay? Welcome back. For this one, we have A is going to be negative 3, so it's negative. The degree is 6. The possible number of zeros is 6. Of course, my domain would be negative infinity to infinity. And so because my degree is 6, but my leading coefficient is negative, it's going to look like this. And it can cross as many as 6 times. How many times have I crossed so far? I got to get 2 more in right quick. There we go. So it looks something like that, the end behavior. Okay, for this one, A is 1, so it is positive. The degree is 5, the number of possible zeros is 5, and of course the domain is negative infinity to infinity. And since it's of odd degree, it's going to look like this. So I'm going to start here, and I'm going to go through 5 times. 1, 2, 3, 4, 1, 2, 3, 4, and then 5. Okay, so that's kind of what the sketch will look like. Now let's talk about a little bit about multiplicity. So when an equation is in factored form, we can find the zeros. We've talked about this before. We would do x minus 2 is equal to 0. We'd add 2 to both sides, and we get x equals 2. That is one of the zeros. So another 0 would be negative 3 and positive 1. The multiplicity is the exponent of the factor. Okay, so in this case, the multiplicity of each one is 1. And if we add up the multiplicity, we get the degree. So in the second one, x minus 3 has a multiplicity of 1, x minus 4 squared has a multiplicity of 2. My solutions are x equals 3 and x equals 4. So my multiplicity, I have a multiplicity of 1 for x minus 3 and a multiplicity of 2 for x minus 4. So when I add these together, 1 plus 2 is 3. This is also a cubic function. In the next one, we have to remember that this is just going to be 0. So I have a 0, and then I have 1 at negative 3, and I have 1 at 2. The 0 has a multiplicity of 1, but x plus 3 has a multiplicity of 5, and x minus 2 has a multiplicity of 4. So remember, I get my multiplicities by the exponent at which it's raised to, and since x is raised to just the first power, it's just 1. So then my degree is 10. 1 plus 5 plus 4. Can you pause the video and do the last one? Okay, welcome back. I hope this 2 didn't confuse you and you thought that that was a 0. It's not, because look, it doesn't have a 2. It doesn't have an x connected to it. It is just a constant. So my zeros are actually negative 4, 1, and negative 3. My multiplicities are 3, 1, 2. So the multiplicities are 3, 1, 2. So that means that it has a degree of 4, 6. It has a 6th degree. Okay? So what is the significance of multiplicity? Multiplicity tells us something about the graph. When the multiplicity is even, we see where the graph will just touch the x-axis. So if I have a root that has multiplicity of 2, it would look something like this. If I have, and then if the multiplicity is odd, it will cross the graph. So if I have an odd multiplicity, it would look like this. So this one has both, all of these have odd multiplicity. So let's look at that let's actually look to see what that looks like. So I'm going to close this video here and come back and watch the next one, please.